Hello, my name is Yashis Rao. Today, I would like to introduce you to a software company called Viridischem, which is addressing the needs related to green chemistry adoption through a suite of products that helps chemists avoid toxicity, reduce waste, and define sustainable product development paths. I will specifically focus on its product, Green Pocketbook, that is available through yearly subscription. Green chemistry includes a set of principles that focus on designing manufacturing processes that aim to minimize the use of hazardous substances while also minimizing the generation of hazardous waste. Recently, there has been a rapid acceptance and adoption of these practices for three main reasons: manufacturing cost saving, brand elevation, and litigation risk avoidance. Green chemistry has already influenced the government and industries, shifting their focus from reactive thinking to proactive action. Instead of monitoring the end product toxicity and then penalizing the companies for their toxic waste generation and disposal, newer government regulations are requiring companies to certify their manufacturing towards more sustainable processes. Because of obvious cost benefits, companies are also proactively focusing on developing production protocols that utilize fewer toxic chemicals and minimize the hazardous chemical waste. This is mainly achieved by toxicity-aware product development research. However, there are three major roadblocks companies are facing while adopting green chemistry. First, there is an overwhelming amount of data related to chemicals which is publicly available. The toxicity data on the starting materials is also practically non-existent. The data needs sophisticated interpretation and is not available in a quantitative format. Chemists and engineers who define these processes do not always fully account for all the toxicity data and do not realize how that impacts the environment, health, and safety. They also lack automated analytical tools which can guide these scientists to make the right decisions. Viridischem is addressing all these problems through its software offerings. We have collected the chemical properties and toxicity data for more than 90 million chemicals from most of the available US and international sources. We translated the textual descriptive data into quantitative measures and then pre-analyzed it in terms of easy to understand ecological, health, and safety scores. As a result, scientists don't have to spend their time sifting through the data and don't need extensive toxicological training to understand a chemical's toxicity impact. Green Pocketbook focuses on presenting the toxicological data and physical properties of the chemicals in an easy to understand visual fashion. It provides most physical properties provided by your typical materials safety data sheet or MSDS based but also includes over 27 toxicological properties. But don't worry, you don't need to pore over these properties to understand the toxicity implications. If you take a look at the graphical view, the product has translated these property values in terms of toxicity scores based on the United Nations, EPA, and REACH guidelines. Very simply, the bigger the shaded area, the more toxic the chemical is. When you compare multiple chemicals, you observe this overlay of areas, which not only shows which chemical is more toxic, but which scores make it seem more toxic. Besides the scores, it also identifies any regulatory concerns related to the chemical shown through a small yellow or red triangle by the chemical name. This triangle can be expanded to get the full list of regulations. I will demonstrate these features in a few minutes. Green Pocketbook can be used by different industries and offers many benefits. For researchers involved in product design and development, when you draw the structure of a new molecule, the product calculates on-the-spot toxicity estimation, which enables early toxicity awareness of drug targets. If you know that a certain toxic reagent or solvent must be replaced with a more sustainable alternative, you can select better chemicals based on a functional group, a category such as a reducing agent or a polar solvent, or specific property thresholds such as melting point or vapor pressure. You can visually compare and select better chemicals and understand the regulatory concerns that go along with it. For environmental health and safety departments, this serves as a precautionary tool to understand how to handle and dispose of chemicals and what safeguards must be taken to avoid accidents. When you integrate it with the lab inventory system, it can help you locate and isolate fire or health hazards to better prepare for emergencies. It also provides essential GHS classification of chemicals and shows this pictorially to save some time. For academic institutes, it quantifies exposure to toxic chemicals in terms of health, safety, and ecological scores. It can help you understand how physical, chemical, and biological issues translates to risk assessment and how structural changes then affect these toxicity scores. You can learn how to utilize these functional groups, chemical properties, and physical categories to identify greener chemicals. So let's summarize the key features of the Green Pocketbook. First and foremost is the comprehensive toxicity data. It shows over 40 physical and toxicological properties on one screen and alerts users to any US or international regulations. The data is curated from over 100 public or government sources. Where experimental data is not available, QSAR models are utilized to estimate the values. It predicts the toxicity of new molecules based on its structure, offering early warnings and awareness of possible problems. There's also the advanced search function. If you require a specific chemical or physical characteristic, but must replace it due to its toxicity, you can select a better alternative by selecting within the same functional group with specific property value range and also by specifying that you want to avoid specific health or safety issues. And lastly, the green scores. They quantify the ecological, health, and safety impact of the chemical and are shown visually, where the area covered by the graph indicates a level of toxicity. You can then compare chemicals by overlaying the graphical charts and choose the best chemical which best suits your needs. So let's take a look at the product in action. Here are 3 organic reaction routes that result in the demethylation of an ether into a phenol. As you can see, each route uses different reagents and solvents to carry out the reactions. First is a boron-bromide reaction with solvent methylene chloride at 0 degrees Celsius. Second is a DMSO reaction with salt at 150 degrees Celsius, and the third reaction involves methionine and methane sulfonic acid at 25 to 50 degrees Celsius. The graphs are generated using Green Pocketbook on the right to show the toxicity of the combination of reagent and solvent for each respective reaction. Just through visual inspection, you can see that option 1 has the highest toxic footprint, while the third option uses the least toxic chemicals. In option 2, the reagent NaCl, or table salt, is not terribly harmful. However, the reaction must be heated to 150 degrees Celsius, which requires excessive energy. Additionally, the solvent dimethyl sulfoxide, or DMSO, can be easily absorbed by the skin, which is why the chronic toxicity score is so high. Long-term skin exposure to DMSO can result in fatigue, nausea, and vomiting. Removing DMSO completely from the final product is a non-trivial task and must be avoided if possible. The third option is methionine and methane sulfonic acid. Methionine is one of the 20 amino acids and is relatively stable. As you can see here, there is a high acute toxicity score, and at high temperature, methionine vaporizes into toxic fumes which are toxic to humans. This is why the reaction temperature is important. At 25 degrees Celsius, or around room temperature, the methionine is stable and safe to handle. Just by a comparison of the green scores, this one stands out as the option that poses the smallest hazardous and toxic threat. A real-life application for improvement of process synthesis can be found in the process of sertraline, an antidepressant. During the discovery stage, the synthesis was carried out in an aromatic, nonpolar solvent called toluene with the reagent titanium tetrachloride. The green scores on the right suggest that toluene is a highly flammable solvent, and both the solvent and reagent have high chronic health scores. This is clearly a hazardous reaction, and during scale-up, it must be improved with a better alternative of greener chemicals to lower the toxicity score. So during manufacturing, the process was improved to involve a single solvent, ethanol. While ethanol still remains a flammable solvent, it can be recovered and recycled easily, As you can see, there's a steep decline in terms of the chronic health scores. This commercial process is a far better improvement and offers much better lab safety to the chemists involved in production. By eliminating the usage of extraneous starting material, it also cuts the cost during the manufacturing processes.
Let's look at the green pocketbook in action. Let's say I'm researching if benzoic acid is a toxic chemical since it is being used in my experiment. So I come to the search bar and I type in benzoic acid and search. So one of the first things you see is the structure. Instead of typing out benzoic acid, a cool function is a search by structure function. If I know the structure, I can draw it out and get the same information. Another really cool option is you can draw new molecules that are desired and have on-the-spot toxicity estimations for them. This can be especially useful in industry practices. The first tab shows me everything regarding the physical properties, ranging from the boiling point to the flash point. Any values that are missing on this tab are estimated using QSAR models. Soon we will be able to show you which values are experimental and which values are estimated. I can click over the Related Information tab. By clicking this, it will take me to the citations and patents which provided this information. GHS classifications, which typically include fire or health hazards, can also be found under this tab. If I go hover over this yellow triangle, I can see the regulatory list which this chemical is found on. If I actually click it, I'll get a printable list. The second list is a toxicology tab. The toxicology tab has the important but difficult to understand information regarding the relative toxicity of the chemical. There are 27 properties found on this list, ranging from the bioaccumulation factor to the ozone rate constant. I can hover over each of these measurements, and as you can see here, it gives you an explanation of the model used to deduce this information. Very soon, you will also be able to see the source of the information and whether the data is experimental or estimated. So there are a large amount of measurements with different values, but no set standard to pool all this information together. So that brings us to the green scores. The green scores takes all this information and compiles it in an easy to understand manner. The scores are based on the 44 endpoints recommended by the United Nations, EPA, and REACH guidelines. It is broken down into 3 top-level scores: ecological, health, and safety. These can be expanded into individual paths, such as water, air, and soil, and within these, I can go to subcategories, which also tell me exactly what was measured. For example, the water exposure was based on the concentration and exposure limit of the chemical. So these scores take the property values, apply a proprietary algorithm to measure a score, and then normalizes that score on a scale from 0, meaning least toxic, to 4, or most toxic. So now let me just give you an example of how scientists can solve their headaches when it comes to choosing what reagents or solvents to utilize using the Advanced Compare feature. By providing the limitations in terms of physical properties, the perfect chemical that suits your needs can be determined. So let's compare some similar chemicals as benzoic acid. Let's say I want the same functional group, which is a carboxylic acid, but let's say I want a different boiling point because the boiling point of benzoic acid is 276 degrees Celsius. So I come to this and I choose boiling point and I set my limits from between 110 degrees Celsius and 120 and I submit. So now it goes and sifts through the database for the chemicals that search my proprietary needs. And let's say I choose acetic acid. The Advanced Compare tools puts these chemicals side by side and I can see the green scores against each other. So let's try one more. Let's search the same functional group, but one that has a different vapor pressure. So I choose my functional group. And so these are the various filters that you can use. I just happen to use boiling point and vapor pressure. So it rifles through the database again. And alright, let's choose formic acid. As you can see, a carboxylic acid. So as we can see, the green scores are overlaid with different colors with a legend at the bottom. and we can have a direct comparison of these chemicals. As you can see here, all three chemicals rank pretty high on chronic health score, meaning that prolonged exposure to these chemicals can have harmful side effects. However, if I look at the red and the yellow, which is benzoic and acetic acid, I can see there are high acute health scores, meaning that short-term exposure is extremely dangerous. However, the formic acid has almost close to nothing for acute toxicity. So I think you can just conclude that selecting formic acid is the least toxic choice and should be used as replacement for benzoic acid in the experiment. So this is just a single example of advanced comparison tools. I showed you there are a lot of different filters which can be used.
Thank you for listening and giving me your time. Please feel free to visit our website at www.viridischem.com or contact us for a free demo at 408-250-6905. Thank you again.